So as people who've been following me for a while know, one of my biggest pet peeves is that we call it AI, artificial intelligence. Real intelligence involves consciousness, reasoning, and comprehension. When I solve a problem, I understand the context, consider multiple approaches, and make reasoned decisions. These systems, they're statistical pattern matching engines. They don't understand anything. They predict the most likely next token based on training data. So calling this intelligence is like calling a calculator a mathematical genius because it can do arithmetic faster than humans. The calculator doesn't understand math. It follows predetermined operations. Same with these systems. It's a marketing weapons grade buzzword. So what are some better terms that actually describe the technology? Well, today we're going to talk about machine learning. We're going to talk about Gen AI, talk about LLMs. We'll talk about RAG. And by the end of this video, you're going to understand what all these different terms mean and actually understand some useful information about capabilities and limitations. AI tells you nothing except that a marketing got involved. Let's dive in today and talk what the real tech is, and I can help you explain a lot of these terms. Welcome to Startup Hack. I'm Spencer, and here at Startup Hack, we train software developers and build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years in software development, I've mastered transforming tech teams and products. So we don't call web search engines intelligent, even though they surface relevant information from billions of pages. We shouldn't call pattern matching systems intelligent just because the patterns are more complex. Let me break down what these systems really are and why they're getting the terminology right, or why getting the terminology right could save your business from costly mistakes. Because as you understand these, it's going to really help you. So let's dive into the term artificial intelligence. This implies sentience and consciousness that simply doesn't exist in current systems. Marketing teams have weaponized the term AI to sell everything from toasters to CRM systems, making the term absolutely meaningless at this point. Real intelligence involves understanding, reasoning, and consciousness, none of which these systems possess. So using accurate terminology helps developers make better technical decisions about which tools actually solve the problem. So let's dive into machine learning, because this really is the core focus of what AI is. It's a branch of artificial intelligence where computers learn to recognize patterns and make predictions from data, rather than being explicitly programmed for every specific task. So instead of a programmer writing detailed instructions for every possible scenario, machine learning algorithms analyze large amounts of data to identify trends, relationships, and patterns on their own. So machine learning is simply having computers write functions instead of humans writing them manually. You feed the system input-output pairs, and it learns to predict outputs for the new inputs. That's classification, not magic. Machine learning has been powering recommendation engines and spam filters for decades without anyone calling it intelligent. The breakthrough isn't intelligence, it's scale and the quality of the training data we can now process. Most AI features in business software aren't just traditional machine learning algorithms. Most AI features in business software are just traditional machine learning algorithms, but with a better marketing spin, and so we call them AI. So understanding this distinction helps you evaluate whether a solution actually needs complex models or simple automation. Now, let's talk about what generative AI is, right? And that's what most people are referring to as AI nowadays. Generative AI produces text, images, or audio by predicting the most statistically likely next piece of content. It's designed to try to give you what you want. These systems are essentially very sophisticated pattern matching engines trained on massive data sets. So the creativity you see is statistical interpolation between patterns that the model learned during training. This explains why generative systems can write sonnets but struggle with basic arithmetic, different pattern types. So recognizing this helps you set realistic expectations and build appropriate human oversight into your workflows. Now, RAG and transformers were one of the biggest breakthroughs that gave OpenAI the surge that it needed when it launched ChatGPT onto the scene in 2022. So let's talk a little bit about what RAG is, because understanding it and its part that it plays can help a lot in understanding where you can put different resources in using AI. So let's say you have a document, okay? And in this case, we're going to talk about, let's pretend that we have a book here, right? And so if we take this book, Retrieval Augmented Generation, or RAG, connects language models to your actual business data and knowledge base. So instead of relying just on the training data, RAG systems search your documents and use that context to generate the response. Let's break down how it does it. So let's say that this document in this case was like a book. You can take this and break it into chunks. So you can take it into chapters, you can take it into paragraphs, you could go by lines, right? You can take it into various different chunks. You send these to specific embedding models. Now, most LLMs nowadays can do the embedding for you, but there's also specific embedding models like Snowflake and others that are designed specifically for this embedding. These then convert these chunks into embedding rows, right? And these are vectors. It then stores this into a vector store. So it's doing some very simple or some complex, not simple, complex linear algebra to take these chunks and convert them into vectors and then store them into a vector store. Now, most new modern databases right now are starting to add vector stores into their database. So like Postgres, we've been using, it works great with this. Now, when a user comes along and says, hey, I want to ask this question about birds, and let's say your book was about all different type of animals, but it says, hey, I want to learn about birds. What the semantic search does is it goes and checks all the different vectors that finds anything near what would be about a bird. And then based on this ranking score from the semantic search, it's going to take just the relevant context, feed that with your question into the LLM so that the LLM has good information to work against. Then it forms your response, right? So where the LLMs are good at statistical pattern matching, it would be virtually impossible to possibly train the model on every piece of data in the world. Even still, this is why the hallucination rates would be so high, was because if you have to trust against that. So the vector store allows it to take the context of just relevant information. So it kind of is like giving it a little bit of a cheat to the test, right? And so the magic happens when you combine the language abilities of the LLMs with the accuracy of your own data. Most successful business implementations I've seen use RAG rather than relying on pre-trained model knowledge alone. So instead of relying solely on what the AI learned during training, which has a knowledge cutoff date, RAG works by first retrieving relevant information from the database, from documents or other data sources when a user asks a question, then feeding that current information to the language model to generate a more accurate and contextual response. Think of it like giving an AI assistant the ability to look up information in a library before answering your question, rather than relying alone on what is memorized in school years ago. This process typically involves converting both the user's query and the stored documents into mathematical representations called embeddings, or these vectors, right? Finding the most relevant information through similarity search, or this semantic search, right? And then combining the retrieved content with the original question to prompt the AI for a well-informed answer. So RAG is crucial for building practical application assistance because it solves the problem of outdated information, hallucinations, and lack of domain-specific knowledge that plague traditional language models. So it's a lot, but it really helps to break this down and understand this. Now, one of the big things here too is that let's talk a little bit about the large language models themselves. So a large language model are basically really sophisticated autocomplete systems that are incredibly good at predicting what comes next in a sequence. So imagine if your phone's autocomplete feature read the entire internet, every book ever written, and millions of articles, then got really, really smart about understanding how language works. These models don't actually know anything in the human way, but instead they've learned patterns from analyzing billions of examples of human writing. So when you ask them a question, they're essentially making educated guesses about what a good response should look like based on all the training data. It's like having a friend who's read everything but has a terrible memory for specific facts. They can give you amazingly coherent answers that sound totally convincing, but sometimes they'll confidently tell you something that's completely wrong because they're just following the patterns, not actually looking at the fact. So that's exactly why we need the techniques like RAG that I mentioned earlier. It's giving that friend access to Google so they can fact check themselves before answering. So LLMs predict the next word in a sequence based on patterns learned from billions of text examples. They don't have any understanding of meaning, truth, or context beyond statistical relationships in training data. So that is why they can write legal briefs but fail at counting letters. Different cognitive tasks require different approaches. LM work best at writing as writing assistants and brainstorming partners, not a source of factual information. That's why we have RAG and other type of pattern database context. So AGI is a fantasy, and that really distracts from the real problem. Artificial general intelligence, or AI or AGI, assumes that we can build human-level reasoning across all cognitive domains. This goal is so poorly defined that researchers consistently move the goalposts whenever systems improved. Chasing AGI distracts from building practical tools that solve specific business problems today. The complexity of human consciousness and reasoning is vastly underestimated by AGI proponents. So focus on narrow applications where current technology actually delivers measurable values is what is most valuable here. So Sundar Pichai has coined a term called AGI, which is artificial jagged intelligence, and I think it perfectly captures the uneven capabilities of current systems. These models show brilliant performance on some tasks while failing spectacularly on others that seem simpler. The jagged nature means you can't predict where the system will excel or completely fall apart. This unpredictability makes them unsuitable for mission-critical applications without human oversight. So I'm sure you recently heard that Microsoft had these big, amazing medical breakthroughs where it did 4 times the diagnosing of humans, but with this little asterisk that it's not ready for, for public consumption because they don't trust it for a bunch of reasons. AGI acknowledges both the impressive capabilities and fundamental limitations of current technologies, and that's where I'm at. This honest assessment helps businesses make better decisions about where and how to deploy AI tools or machine learning or RAG or LLMs or whatever, right? So building demos is easy, but production systems that reliably deliver business value are incredibly difficult. Most companies underestimate the data preparation, validation, and monitoring required for successful deployments. Real-world constraints like latency, cost, and reliability often make sophisticated AI solutions impractical. Now, if your company has systems that aren't connected and you need some help getting them connected, reach out to us, because here at Startup Hack, our specialty is connecting these systems to help your company work to absolutely maximum efficiency. So check out startuphack.com/Spencer. Now, companies are quietly reintroducing human verification after discovering the cost of errors exceeds automated savings. The most successful implementations enhance human capabilities rather than attempting to fully replace them. So the most successful deployments have clear metrics and measurable business outcomes from day one. Too many projects are launched on faith or hype without defining what success actually looks like. Or a better way to put it is, there's a bunch of people running around with a solution called AI trying to find a problem to solve. Generally, good businesses are problems that find solutions, right? Measuring impact requires understanding baseline performance and tracking specific improvements over time. The companies that survive the current hype cycle are those delivering measurable values, not impressive demos. So I can tell you that the ROI reckoning always comes, and it's going to be pretty brutal for some of these huge AI systems that have these crazy levels of valuation. So again, if your company has systems that aren't connected, reach out to us, because here at Startup Hack, our specialty is connecting systems. Now, I'm also doing a great demo on how RAG works and how it works with LLMs. So stay tuned and make sure you like and subscribe and leave a comment down below, because I'm going to link it up here so that you'll be able to see once we get that dropped. But follow along, because we will be dropping, and I'm going to be giving code samples for exactly how to build your own RAG system. Now, what are your thoughts? Do you agree? Do you disagree? I love to have a great discussion, so make sure to leave a comment down below and make sure to like and subscribe. And here's some great information about our services.
Hi, my name is Spencer Thomason, and I'm a fractional CTO. With over a decade of executive leadership and a solid 25 years in software development, I've mastered the art of transforming technology teams and products. So what is a fractional CTO? This is where you can contract someone like myself to come into your organization and get the benefits of a seasoned CTO without having to employ me full time. In today's fast-paced world, efficiency, security, and product scaling aren't just goals, they're necessities. My passion is building impactful products and enhancing organizational efficiencies through technology. From startups to small businesses, my approach leverages lean methodologies to not just meet but exceed your strategic goals. Whether it's through executive mentoring, cloud system architecture, or launching a minimum viable product swiftly, my aim is to make a significant impact right from the start. Recognized in the Arizona startup ecosystem, my journey has been about creating value and fostering innovation. I have led technology for companies like GoDaddy, SRP, and Wells Fargo, and turned challenges into milestones. I've taken this learning and launched 7 of my own brands, and now I want to help you. So if you're looking for a fractional CTO who brings a wealth of experience, strategic vision, and a proven track record, let's connect. Together we can build technology that not only drives your business forward, but also makes a difference. Technology leadership redefined to fit your needs. So reach out today.